So again, we want to welcome everyone to tonight's webinar on extreme weather in southern New England. I'm Joe Deli Carpini, the Science and Operations Officer, and with us tonight we have a new face, Nicole Belk, who is our Senior Service Hydrologist. Nicole manages the office's hydrologic program. Last summer she was quite busy with the drought, so we welcome Nicole. She's helping us out with her first webinar and hopefully will help us out again in the future. And Bill Leatham is with us too. Bill, as I mentioned, manages our climate program and did a lot of the work to putting this presentation together, both he and Nicole. So I appreciate your help, guys, and welcome aboard. So Bill, I'm going to hand it off to you. We're going to start with a look at temperature extremes, and then Nicole will take a look at precipitation, including snowfall, and I'll wrap it up with a look at hurricanes and tornadoes, more the extreme ones. So Bill, I'll hand it over to you.
All right. Well, good evening, everybody. So starting off here, the thing that I had to take a look at for the temperatures to kind of delineate, you know, what the record days were was we used our four climate sites, which was Boston, Providence, Worcester, and Bradley. That's what we were looking at in the temperatures for the highs and the lows. But I do want to make note, and you can see on the right-hand side here in the table, so even though we're looking at the records for our climate sites, that's not necessarily the state records. As you can see, for the high temperatures in Massachusetts, Chester had 107 degrees in 1975. Providence was 104 in 1975 on that same date in August. And then you can see in Connecticut, two different sites tied at 106 degrees in 1916 and 1995. But the first date that we're going to look at is July 4th in 1911. So the heat wave from July 2nd to 6th in 1911, if you look at our daily climate sites, or the climate sites that we mainly focus on, Boston, Worcester, Providence, and Hartford. Boston and Worcester, it was their first, the highest temperature they've seen on in a single day on July 4th in 1911. Boston came in at 104 degrees and Worcester was at 102 degrees. Providence was at 94 and Hartford, Connecticut at 99, which ties the 28th. One thing I should point out is that the Worcester location at this time was in a different, not in exactly the same spot it is right now. So it probably would have been a bit cooler if it was at where the regional airport is at this point. But going forward, you can take a look. So to kind of take a look at the meteorology that's going on in these events this far back, there's a couple different entities that do what they're called reanalysis, and it uses all sorts of different kind of data to kind of get an idea at what what was going on. There's a bunch of different observations that go into it, but this one is a 20th century reanalysis, which actually goes back to 1836. You can actually look at maps like this. But the big thing with this event, probably unsurprisingly to folks, is we had a ridge that was kind of sitting over the Great Lakes region, and it gradually built further eastward as time went on. And because of that, we were stuck under high pressure through that whole time frame, which is what allowed us to see the record temperatures that we saw, with, again, the 4th being where the warmest readings were. And if you go to the next slide. Now here's some impacts from the event. Now all of these photos are actually from the New York City area. As you can see, there's some horses drinking water in Union Square towards the end of the event. There's people resting in the park because obviously at this time there really wasn't any sort of air conditioning or anything like that. And then kids on the streets licking blocks of ice that were left out. Now I don't have a photo of it, but at least through some reading, there were people doing same kind of things of, falling asleep in like the Boston Commons. They said there was lots of folks that were out in the Commons sleeping. So moving on to the next heat wave, which was from July 31st to August 3rd in 1975. Now this was the hottest for Providence at 104 degrees. But for Boston, Worcester, and Hartford, they still fell within the top 20, and you can see the temperatures on the side there. Now, one thing that was interesting that I noted from the Weather Bureau's analysis of the surface map on this day is you can kind of, it might be a little hard to read, but it does say one of the hottest days in New England history, the record high minimum at Boston for July, which was, it's tied with right now with a value in 2019 of 83 degrees was the low temperature on August 2nd. So really, really, really warm. Not really much relief at night. And so this is another one of the different models. Reanalysis is a little more up to date in a higher resolution model, the NCEP and NCAR reanalysis. And what you can see here, kind of the same kind of situation as the previous. You've got a ridge that builds from the upper Mississippi River Valley and can slowly build eastward until it moves offshore. And it's not until the 4th where we get a cold front that works its way through, which is when we see the relief from the heat wave. But it's because that high is sitting over us and just keeps us under the warmth for such a long time. And then, unfortunately, I didn't have any images from that last one, but going into a little more recent, the heat wave from July 19th to 23rd in 2011. For this one, this is Hartford's warmest day on record at 103 degrees. But again, all of our other climate sites still fell within the top 20. And then this is just an image from towards the end of the heat wave, where this is where the relief comes in as that cold front passes through and brings in a cooler air mass. But if you go to the next slide, you'll see it's kind of the same situation as the past couple. You've got this ridge that just kind of sits over the plains and gradually builds eastward. And then it's once we get a cold front that moves through a little later in this heat wave is when we get out of that really hot air mass. So to go away from the record highs, now we're going to go to the opposite end of the spectrum, which is the coldest temperatures. And you can see the dates on the left-hand side are what we're going to cover for the climate sites. But on the right-hand side are the state records. For Mass, it's 35 below zero with those 3 different locations, 28 below zero for Rhode Island, and then 32 below zero for the two locations in Connecticut. So for February 9th, 1934, this was Boston and Providence's coldest temperature in the period of record for the stations. At 18 below zero for Boston, 17 below zero for Providence. Worcester was at 20 below zero, and then you can see that Hartford was at 15 below zero. And then this is the Department of Agriculture. This is the old Weather Bureau map analysis that they took at the time, and you can see that there's a high pressure that's kind of centered over Ontario, Eastern Ontario. So going into some of the model output for that time frame, you basically got a ridge. It's kind of pretty similar to what we were looking at with the record heat, but obviously in this case is the cold. You've got a ridge that builds from our west gradually further east. And then the big thing is you've just got this honking Arctic high over us. It's actually like a 1040 plus millibar high by the model, which is really, really extreme. It's pretty cold. So if you want to go on the next one. Now this is for February 16th, 1943. This is Worcester's coldest temperature on record at 24 below zero. But you can see for the other sites, they all fell within the top 20. But the interesting thing in this case is the high, instead of being over Ontario, it's over the Central Plains and into the mid-Mississippi River Valley. So looking at this, from February 15th to 17th, 1943, you've got this big ridge over the western U.S. gradually building further east. And because of that, we've got a Arctic high that's centering over the into the Central Plains and then Mississippi River Valley as it gradually builds further east, and that's what kept us in that really cold air mass. And then lastly, this is actually one of the more interesting ones out of all of these events because it's a little counterintuitive because you've got a low over the Great Lakes and then a high in the in the Gulf. Now this is actually Hartford's coldest temperature on record at 26 below zero. But as you can see for the other locations, it's not that it's not cold, but it's really not too cold. And when you compare it to all the other daily cold temperatures, with Boston being at 6 and Worcester at 0, it's way down on the list for all-time daily minimum temperature rankings. So if you go to the next slide, it's interesting because there's basically just a trough over the eastern half of the country and a ridge over the west. Now I was going to actually talk to Joe about this too, but it's kind of hard to tell even by the surface analysis by the model here. But my guess would be, just looking at what's going on, we've probably got some sort of cold air damming that's going on, which is why Hartford got as cold as it did with that low that's over Nova Scotia. We probably got just a lot of cold air filtering into the region, but that's why it got so cold for Hartford, and it wasn't as cold in the other locations because they're not in a valley. And then with that, I will pass it along to Nicole to go over the record daily precipitation.
Thank you, Bill. Okay, so next we'll take a look at record daily precipitation events for our major climate sites in Hartford, Worcester, Boston, and Providence. The records occurred during 3 different events that we'll take a look at: October 13th of 1895, August 19th, 1955, as Diane tracked across or made its closest approach through our area, and August 4th, 1979. So first here, we'll take a look at October 13th, 1895. It was the all-time wettest day on record at Worcester, with 7.54 inches of precipitation. It was also the 8th wettest day on record for Boston, which had 4.85 inches of precipitation that day. For Providence and Hartford, this was actually outside of the period of record for those 2 locations, so we don't have the amounts from this particular event. The map on the left shows the weather for that day. We had a coastal low bringing onshore flow into the central and eastern portions of our area. And a closer look at the map shows some southerly winds around the Cape and the islands, and also winds from the northeast around the Boston area. So there was a frontal boundary in the area as well. Now on the next slide, we'll take a look at the broader weather pattern from October 12th to the 14th. And again, this is the reanalysis maps, as Bill referred to on the earlier slides. On the map on the left, in the mid-levels of the atmosphere, we had a trough of low pressure moving through the area. And then on the right, you can see the area low pressure very slowly moving through our region over the 12th to the 14th, so it wasn't moving terribly fast. And on the left here, we have a plot showing precipitable water, which is a way to measure the amount of moisture in the atmosphere. And you see here we have to the south in the Gulf of Mexico and going up the Atlantic coast, there's a bit of a plume of tropical moisture, and it briefly comes up into our area, probably right around October 13th, and right when we had this heavy rainfall event. Now that tropical moisture plot, the value for the Chatham area was fairly high, around the 90th percentile for this time of year. So it was a pretty good but brief shot of tropical air coming through the area. So now taking a little bit closer look at where some of that tropical moisture came from, and it was actually an unnamed tropical system. So on the 13th, we had this unnamed system that formed in the far southern portion of the Gulf of Mexico in the Bay of Campeche, and it was to track northeastward over the next several days. And that happened to be the source of that deep tropical moisture that briefly came up around, extended into our area. So the next daily records that were broken came from Hurricane Diane, August 19th of 1955. Looking at the table on the right, Boston had its all-time wettest day on record at 7.06 inches. Hartford also had its all-time wettest day on record at 7.7 inches. Worcester had its second wettest day on record at 6.38 inches, while Providence was spared most of the heavy rainfall. We'll show the track of Diane on the next slide, but first we want to go back just briefly to the map. Yeah, thank you. So here's the analysis of that morning from August 19th, where you can see Diane was coming off the New Jersey shoreline. And on the next slide, we'll take a look at the track. So, thank you. So the map on the left shows the track of Diane's eye, or center, is indicated by that thin yellow line, as well as the precipitation. Keep in mind the rainfall totals on the map on the left and the table on the right are multi-day and not just for August 19th itself. Hartford, Worcester, and Boston were all within that heaviest rainfall swath that you see painted in purple and the deeper blue, which was 10 to 15 and even up to 20 inches of rainfall. Hartford, Worcester, and Boston were all within that area. However, the biggest rainfall total for anywhere with this event was Westfield, Mass, where you can see on this table right at the top with 19.75 inches of rain, which is just an incredible amount of rainfall. And you can see, just looking at this listing of event total precipitation for a number of locations across southern New England, that it really will, even though Westfield had 20 inches of rain, we still had many places that had 10 to 17 inches of rainfall. So now we'll take a look at the mid-levels of the atmosphere and also the track of Diane. On the left, if you kind of look towards the tail end, we've got this trough that comes through the Great Lakes region, right towards the end here, yep, and sweeps across New England. Now, the same time that that's coming through, on the right, we have the sea level pressure, and you can see Diane's coming up in just about the same time as that trough moves through. So what we're getting is a form of an extratropical transition for Diane. By the time Diane made its way up into our area, it was weakened down to a tropical storm, but obviously still had copious amounts of rainfall. And with the extratropical transition, what you typically get is the heavier rain falling to the left of the track and the stronger winds to the right. And in this case, since Diane was tracking right along Long Island and moving eastward, as it brought its rains over our area, Massachusetts, Connecticut were all left of track. And so it made sense that we managed to get some pretty hefty rainfall totals with this particular event. So looking at the precipitable water associated with Diane, the moisture on the map on the left, it peaked around 62 millimeters, which is colored in that yellow. Yeah, you can see it on the loop there. It kind of increases in moisture as it moves up towards New England. And on the right, again, this is a broader view of the track of Diane from the time it was a tropical depression until it moved off into the northern Atlantic. And you can see where it's green, that's where it had weakened down to a tropical storm. And again, as I mentioned, that with that extratropical transition left of track, we get the heavier rain. And that happened to be right where southern New England was located. And we did get the most rain. So the flooding impacts were severe, producing widespread flooding across a good portion of Massachusetts and into Connecticut. This picture on the top left is from Windsor, Connecticut, downtown area, I believe the Mad River. It was right near the downtown area, and it brought waters up to 10 feet deep through the center of town. Resulted in one whole side of streets, buildings being permanently torn down. The picture down on the lower center was from Worcester with flooding, and you can imagine that there was a lot of flooding in the Worcester area with this amount of rainfall. There were record floods on a number of rivers in the region. With Worcester, a lot of the water there and south drains into the Blackstone River. So we had record flooding in Northbridge and Woonsocket, the Quinnebog River in Connecticut, and even the Charles River in eastern Mass. Yeah, so it's definitely catastrophic rains. One of the things to note too is that Connie had come through about a week earlier and produced a soaking rainfall. Obviously not flooding like this, but with that rain, it helped to saturate the ground and boost the rivers and streams so that when Diane came through, the flooding was even worse. And here's a photo from the Naugatuck River at Beacon Falls in southwest Connecticut. Just again, another phenomenal amount of flooding that went on from Diane. And one of the things also to mention is there were about 200 lives lost with Diane from Pennsylvania northward into southern New England. And finally, just a couple more photos here. Sadly, one of the things that also happened with these rains was we had dam failures. And the map on the left is a dam failure photo, obviously after the floodwaters had receded at Glen Echo and Charlton, Mass. The map on the right shows damage to mills and an electric company on the Blackstone River at Manville. And one of the cases with the Blackstone River was we had cascading dam failures. So one dam would fail, the next one downstream would fail, and this really exacerbated the amount of flooding going on in that area. So the last record-setting rain event at one of our major climate sites was from August 4th in 1979. And this one's kind of a little bit different from certainly different from Diane, but the heaviest rainfall center actually happened right in the Providence area. Yeah, we'll take a look at the next slide here. So here's a look at the reanalysis. On the right, you can see a kink in the pressure here, and there was a weakening front that was moving into and across the area. So it was moving through, and on the left, in the mid-levels, there wasn't a whole lot going on. We did have a weak trough going into the area, and I'm sorry if I could back up the slide just to the previous slide briefly. Thank you. Yes, I should have mentioned here on the weather map here, we had a plot of a front. So there was a weakening front that was draped across the area as well, with the moisture obviously on the southeast side of the front. So you can go ahead. Okay, thank you. So on the left, again, taking a look at that precipitable water, we did have some tropical moisture that kind of skirted along and into southern New England during this time frame. And as it happened, on the right, we had an unnamed tropical depression that happened to be coming paralleling the eastern seaboard. It obviously didn't give us a direct hit, but it did provide some tropical moisture along that front. So here's a look at the heavy rainfall from this event. And you can really see here the heaviest rain was primarily confined to Rhode Island and southeast Massachusetts, where we had anywhere from 2.5 to 6 or so inches of rain. And there was much less precipitation as you went into, say, northern Mass and north central Connecticut. So in this case, the heaviest rain was confined mainly to the frontal boundary and was enhanced with that tropical moisture. And so here's a chart on the left kind of showing some of the rainfall totals that we had in the region, with Providence being the highest there at 6.31. And then we had some amounts from 4 to 5 inches. It was a generous rainfall for southeast Mass and Rhode Island, but drier elsewhere in the region. And again, we had that weakening front that slid through southern New England, and the front managed to interact with some tropical moisture from an unnamed tropical system. So just to make a mention here for our biggest floods, and obviously the rains that came through as Diane tracked south of our area as a tropical storm, that was really one of the big historical flood events for our area. But some of our biggest floods have been multi-day events. A more recent one being March 2010 in Rhode Island, where we had a series of rain events, and by the time we got to the end of the month, there was no place to put the water. In this case, I want to show you a couple of the biggest regional flood events that historically we've had. This one is from March of 1936, and it wasn't just from rainfall, but it was also from snowmelt. So the map on the left shows both the combined rain and snowmelt that occurred over the region from the 9th to the 21st of 1936. And it's not just in southern New England, although it's mainly in interior southern New England. You go all the way up into eastern Vermont, into New Hampshire, and obviously Maine too. You get into the headwaters of the Connecticut and the Merrimack rivers. And this picture here on the right is actually from the Merrimack River in Nashua. The Merrimack had its record flood from this event. The Connecticut River had its record flood from this event. So this was really a huge flood event for the region. And this last one, just to mention, September 38 with the 1938 hurricane. Again, the map on the left shows the precipitation over that region. We had 5 to 12.5, and some places even greater than that, rainfall across the region from September 17th to the 22nd. And it wasn't just from the rains directly with the hurricane as it came through. There was actually heavy rain and moisture out ahead of it too that really turned this into a multi-day event. And again, getting up into not as bad as the 36 flood, but those heavy rains got up into a lot of the mid and upper Connecticut River and Merrimack River drainage areas, and we ended up with more. It ended up being the second worst flood on the Connecticut and Merrimack rivers, with the worst being from 36. This one was a close second, and the picture on the right shows the Connecticut River at Hartford with the floodwaters associated from the freshwater flooding standpoint. And now for the record daily snowfall, I'll hand it over to Joe.
All right, thanks, Nicole. And actually, I'm going to hand it over to Bill, who's going to talk about this, and then I'll come back for the hurricanes and tornadoes. So, Bill, go ahead and take it away for the snow.
All right, so going into the record daily snowfall events, you can see the dates on the left-hand side, two in February, one in 1961 and the other in 2003. And then we've got January 12th in 2011 and January 27th in 2015. But you'll note that the Blizzard 78 is not on that list. So we're going to have it as an honorable mention here, the Blizzard 78. Now, if you take a look on the right-hand side, it's got the highest daily snowfall totals from the Blizzard 78. Where for Boston on the 7th was 19 inches of snow, which is actually the 6th all-time daily snowfall ranking. Worcester had 10.1 inches of snow on the 6th and the 7th, which is the 86th for Worcester. And then you can see Providence and Hartford. Providence came in at second at 18 inches of snow on the 6th, and Hartford had 12.8 inches on the 6th, which is down in the 25th. But you'll see a little more about the Blizzard 78 at the end. Don't worry, we won't skip over it. So first we'll start with February 4th in 1961. So in 1961, this was the record daily snowfall for Providence, Rhode Island, which came in at 18.3 inches of snow. You can see the other snowfall amounts for the other climate sites, still all within the top 20 for the locations. And on the left-hand side, you can see that there is a nor'easter beginning to develop just off the coast of Delaware. And this is from the Weather Bureau's analysis at 1 a.m. And if you want to go to the next slide, Joe. So looking from February 3rd to 5th in 1961, on the left-hand side, you can see what the upper level weather pattern, and there's a trough that is digging its way in from the Ohio River Valley into the New England area, and then eventually lifts offshore towards the end of the 5th. But if you look at this, the low, we kind of saw in that previous, on the surface analysis. The big thing is the low is deepening as it moves northeastward. And one thing you'll note is that little black circle is something that you'll see us talk about in our area forecast discussions a lot. Is the low just passes right over what we call the benchmark, which is the 70 degrees west and 40 degrees north on a latitude and longitude, and that usually signals some big snowfalls for us. So if you want to go to the next slide, we're on to the next snowstorm, which would be the President's Day snowstorm of 2003. On the left-hand side, you can see the snowfall map across the region, and much of southern New England had anywhere from 1 foot to 2 feet of snow. And for the climate sites, this was actually Boston's highest daily snowfall on February 17th, just under 2 feet of snow at 23.6 inches of snow. And then you can still see nothing to snuff at the other sites being over 1 foot. And again, all falling within the top 10, top 15 for all the other climate sites. So if you want to go to the next slide. And so on the left-hand side is just a visible or is an infrared satellite imagery of the storm on the 17th. You can see the system moving towards the region, but this is another case where we have a nor'easter. We got a secondary low that develops off the Virginia and North Carolina coasts to a little later in the period. Unfortunately, there's no timestamps on that. And then it moves northeastward, and that's what brings us the heavy snowfall. And then jumping on to the next snowstorm on January 12th in 2011, this was Hartford's highest daily snowfall at 2 feet of snow. And still, again, nothing to snuff at the other locations, all falling in the top 15, with the locations being above, above 1 foot, if not close to 2 feet, with Worcester at 21.1. But you can see here that this was pretty, especially across the eastern slopes of the Berkshires. There's it looks like it's a little bit of an elevational component for parts of southern New England, where, and on that map, you've a 2+ feet of snowfall in some locations. So if you want to go to the next slide, Joe. So this is showing that we've got a trough on the left-hand side. You've got a trough that's lifting from the mid-Mississippi River Valley. It goes through the Ohio River Valley and into the Eastern Great Lakes and through New England during this period, moving through on the 13th. And again, kind of almost similar to the last 2 snowstorms I talked about. We've got a low that develops off the coasts of the Carolinas, secondary low, and it deepens as it moves northeastward towards southern New England and brings us the heavy snowfalls. But one thing you can notice here with that low track, the low is a bit closer inland versus staying a little further offshore. It moves more over like Rhode Island and eastern Mass, which is why we see those heavier snowfall bands setting up a little bit further to the west. If you want. And then, so then this is the next snowstorm, which is I'm sure a lot of people remember, it's the January 26th to 27th snowstorm in 2015. It's the first major storm of the 15 snow blitz. And you can see the snowfall values with a lot of places over 2 feet. And you can see on the map there that, all the highest snowfall totals are pretty much from central parts of where we forecast, and going further east, but this would be the highest snowfall, I believe, for Worcester. So if you go to the next slide. Yep, so this is Worcester's highest daily snowfall, which was 31.9 inches of snow. And again, nothing to snuff at for Boston and Providence, being over 1 foot or close to 2 feet, but really not that much for Hartford, only 6.3 inches of snow. But again, this is the first storm of the winter blitz of 2015. So taking a look at the weather pattern, on the left-hand side is the upper level pattern. Again, you see a trough that digs from the mid-Mississippi River Valley into the southeastern U.S., and then eventually it cuts off right over us before it moves offshore later on the 28th. And so when this happens, we get a secondary low that develops again off the Carolina, Virginia coast, and passes just southeast of Cape Cod, and before it lifts into Nova Scotia. And that's what brings us the heavy snowfall. Now, I think this passed right over the benchmark as well, but this is a tough, that weather map that we have there doesn't show the latitude and longitude, but that's why we got the heavy snowfall that we got. So, like I said before, we can't, even though we talked about the other snowstorms, we can't forget about the blizzard of 78 from February 6th to 7th. And again, it's the benchmark, considered the benchmark of winter storms. And it kind of had a similar feel to what the past few, storms that we talked about, which was that it meandered offshore, brought high winds, record snowfall, and the other thing that we didn't mention with the other storms, this one brought coastal flooding. Now I know the other ones did as well, but to some degree, but this brought some real significant coastal flooding. And the big thing is that it kept things at a standstill for over a week. And I'm sure there's some folks in here that probably remember this storm pretty well. So if you want to go to the next slide. So going into the what the reanalysis data shows from February 5th to 8th in 1978, you have a deep trough that digs from Ontario into the Ohio Valley and mid-Atlantic before it cuts off as it's right over our region towards the end of the slide here, and then eventually it moves offshore on the 8th. And kind of what I've been saying the last couple, it probably seems the same. Secondary low develops offshore of the Carolinas and deepens to the south and southeast of southern New England before it moves offshore. But again, it goes right over that 70 degrees west, 40 north, which is again, we talked about on the 1961 storm, the benchmark, which brings us pretty heavy snowfall. If you go to the next slide. So if folks can remember this, I don't know if folks do, this is actually forecast real well several days in advance. There was a winter storm watch that was issued in the morning, 30 hours in advance, and heavy snow watch issued in the afternoon. Near blizzard conditions were forecast 15 hours in advance. However, what caused the big issue was that the heavy snow occurred a little bit later than was predicted. And so because of the snow happening a little bit later, folks had headed out to work, and they were skeptical that, hey, this was another forecast bust by the weather forecasters. So with that, I'm going to pass it along to Joe here to wrap things up with the hurricanes and tornadoes for southern New England.
All right, thanks, Bill. So now we'll flip the coin and go over to all things tropical. So we're going to take a look at the strongest hurricanes at landfall here in southern New England. So that includes the three you see listed there: the New England Gale of 1869, of course, the 1938 hurricane, and Hurricane Carol, which was the last major hurricane to strike southern New England. It's been a long time. And our honorable mention is the Great Colonial Hurricane of 1635. We don't have a lot of information on that, and that's why it's not in our top three, but it certainly was a very devastating storm, and we'll talk about that first. This was probably the strongest hurricane to ever strike southern New England, but obviously back in the colonial times, the data was pretty limited to people's weather journals and ship logs. So what we do know through a reanalysis from actually the National Hurricane Center was it was a Category 4 storm at some point in its peak, and it was a Category 3 at landfall when it struck pretty close to the shore around Westerly, Rhode Island, Groton, Connecticut, that area. It was estimated that the maximum storm surge was about 20 feet into Buzzards Bay, and the peak sustained winds of 135 miles per hour. Now, we do know from the journal some of the impacts of numerous trees and houses were completely destroyed, along with some devastating coastal flooding, and the damage was still noted about 50 years later. The governors, as it says here, of Massachusetts Bay and Plymouth Bay colonies described very high winds, surges of 14 to 20 feet, on the south coast of Rhode Island and southeast Massachusetts. So obviously this was a very sizable storm, and through some work with the National Hurricane Center, they actually went back and did some reanalysis of the storm and were able to come up with some of these estimates. But again, it's kind of all we can go on, their estimates. So we'll include this one as an honorable mention, and certainly it could be at the top of our list for strongest hurricane landfalls here in southern New England. So we'll move on. Here's the New England gale of 1869. And this, again, using our reanalysis maps, courtesy of Bill, who put all these together. You can kind of see that the storm was kicked out to sea. The reanalysis isn't perfect, in other words. So sometimes we can run these with pretty good success. But here's the actual track. It actually came through as a Category 2 storm into, looks like, southeast Connecticut again, but the reanalysis actually showed the storm kind of getting kicked out to sea. So not a perfect simulation there. Now, of course, the 1938 hurricane is more well known in these parts. It had a long track. This was what's called a Cape Verde storm, one that formed well out over the Atlantic off the west coast of Africa, kind of churned its way along the Atlantic, strengthening due to all the heat and moisture that's available, and eventually made the curve up the coast and made landfall in Connecticut. This is the actual surface map prior to that you can see here. It's off the coast of the Carolinas, and was making pretty much a beeline right for southern New England. Now, back in the day, here's an actual headline from the Westerly Sun a day later, and I mean, they're not mincing words here at all. Misquamicut wiped out, Napatri Point gone, 50 dead, scores missing. So this was not, kind of trying to make headlines. This is actually what happened. It was a very devastating storm. Now, Bill actually went through and kind of did what's called a hindcast. He ran a computer simulation to kind of show what happened, and you'll see some pretty neat images here. So on the left is our 500 millibar, or about 18,000 feet. It's our steering flow, and you can see there's a big low pressure system. It's called a cutoff low because it's cut off from the rest of the jet stream. And as this loops again, we'll show kind of the interaction. You have this deep trough starting to cut off here. And as the storm actually makes its way up through the Caribbean, it actually gets kind of influenced by this cutoff low sitting here. It's almost like a magnet where it's pulling it in, drawing it toward the coast as opposed to kicking it out to sea. And eventually it kind of gets absorbed here, as you can see, and moves in across upstate New York. Well, here's the surface simulation. You can see the storm is starting to enter the picture here in the Caribbean. We've got high pressure sitting off the coast. So where does the storm go? It kind of goes to the path of least resistance, which is up here off the coast of the southeast U.S., kind of parallels the Carolinas, and then makes a beeline here into southern New England. Probably this is a little bit farther west than what actually occurred, kind of moved closer to the old Saybrook area. But it made landfall as a Cat 3. Now, what's really neat, and Bill gets extra points for this, is he actually ran a simulation from the computer model of satellite and radar, and you can see both of these here, satellite on the left and the radar on the right. So take a look as this loops through. It's a really neat simulation. One thing to point out, and I'll wait till it goes through the loop again, as you see the storm approaching, let's wait for this to start again, you see this front kind of coming across, and you see all this tropical moisture. It looks like there was a little bit of a heavy rain event before the storm even got here. You can see these showers and probably thunderstorms dumping some locally heavy rain, which kind of primed the event for some good significant flooding as the hurricane moved ashore. And now you can see the main thrust of the hurricane comes through. So there definitely, it seemed to be some what's called a predecessor rainfall event. We get these bands of heavy rain a day or two ahead of the actual arrival of the storm. And that usually is what primes us for significant flooding with tropical events. So, Bill, really good job here. This is really cool stuff. So I'm sure some of the damage, obviously, was devastation throughout much of the region. In Rhode Island, a couple of images there, across the Connecticut coast as well. Houses destroyed from storm surge and high winds. Also in Woods Hole, devastating flooding, freshwater flooding out to the west where the heaviest rain fell, Springfield and Ware, Mass. See some of the images there. And then we move on to Hurricane Carol. Again, Carol was the last major hurricane to make landfall in southern New England, so it's been a while. And you can see the weather map here of Carol over southern New England, and the track of Carol started in the Bahamas. So that's why our general rule of thumb, if you've been with us before, we say anything with a name in the Bahamas is our business, and it certainly is, because they tend to want to make a beeline up for our area or just come pretty close, at least give us some effect. So in this case, Carol came up right through Connecticut. And here's the reanalysis, again, courtesy of Bill. Pretty, typical setup here for landfall in southern New England. You can see there's a fairly large trough or low here over the Great Lakes, which kind of steers things up to the north. And you can see as Carol hugs the coastline and eventually makes landfall on eastern Long Island as a Category 3, and then into Connecticut also as a Category 3. That was back in 1954. So yes, we are long overdue for a major hurricane, if not even just a hurricane landfall here in southern New England. So some of the stats on Carol: sustained winds of 80 to 100 miles per hour across eastern Connecticut, Rhode Island, and much of eastern Mass. Obviously, a lot of destruction to trees, power lines, and crops. Block Island, in fact, recorded its strongest wind gust ever, 135 miles per hour. There was extensive coastal flooding along the coasts of Connecticut, Rhode Island, and south coastal Mass. And the largest surge within Narragansett Bay and New Bedford Harbor, with over 14 feet of storm surge. Again, just to the right of that track is where we see our strongest winds and highest storm surge. So certainly a devastating storm. And a few clips here from the Vineyard Gazette back in 1954. You can see a boat ended up in someone's fence. A lot of damage in one of the harbors. I believe this is Vineyard Haven. So certainly inflicted a lot of damage on the Cape Islands and even Block Island. So we're going to finish up here with a look at our strongest tornadoes by state. I think you'll recognize most of these if you're a fan of severe weather or even just weather in general. For Massachusetts, it was the Worcester Tornado back in 1953, which was an F4. In Connecticut, it was the Windsor Locks Tornado on October 3rd of 1979, which was also an F4. And in Rhode Island, it was a Providence Tornado. Also, there was one in Cumberland that day, August 7th, 1986, an F2. And of course, we have to give our honorable mention to the Springfield Tornado on June 1st, 2011, which was an EF3. And I've got some very interesting comparisons to the Worcester Tornado. So let's start with the Worcester Tornado. And this is not an exact track, but just showing the line of essentially the damage. Of course, it wasn't a perfect straight line. And it was actually a second tornado to the south of that from Millbury over toward Mansfield and Foxborough, a weaker one. But this was an F4 tornado, estimated winds 210 to 261 miles per hour, over 1,200 injuries and over 94 fatalities. It had a path length of 35 miles and a maximum width of 900 yards. Certainly almost kind of a once-in-a-lifetime event. So what was happening that day? Pretty classic setup for tornadoes here in southern New England. There was a warm front approaching early that morning with a cold front coming from the Great Lakes. And in fact, the day before, there was a tornado outbreak in Michigan that kind of happened ahead of our severe weather day. And that's typically a severe weather sign for us. If there's widespread severe weather in the Great Lakes with an eastward moving cold front, we tend to see it the next day, and this was no exception. And that afternoon, actually, the warm front crossed through our area. We were called that we're in what's called the warm sector ahead of the cold front, warm and humid air. And again, this is a fairly typical setup for tornadoes in southern New England. We actually got hold of a weather map from that afternoon of June 9th. This was sometime around 3 or 4 p.m. You can see the warm front has lifted through much of the area. It's getting into the Boston area at that point. Cold front is still back across close to the Catskills, and this is what's called a little bit of a surface trough, an area of kind of wind convergence. But at that time where you see the star, there was actually 3-inch diameter hail and what was called rotating wind damage in Coleraine, Mass. And that probably was another tornado. And we had baseball-sized hail reported in Northfield, Mass. Around 3:45 p.m. So again, similar to June 1st, 2011, a lot of large hail reports. We had several reports of baseball-sized hail that afternoon of June 1st in the Berkshires with the storms that developed. There's actually one of the first radar images as radar was being kind of developed and refined in the 1950s. This was from an MIT radar, which was located over in Lexington, Mass. And it shows a hook echo signature, which you're probably familiar with. Again, if you're a fan of severe weather, this indicates a tornado, and it was located over Holden, Mass, which is just a little bit to the north and west of Worcester. So first radar image, and this was taken at 4:55 p.m., shows the tornado before it hit the greater Worcester area. Now, I was also able to dig up some of the weather observations from Worcester Airport that day, and you can see, if you follow my cursor here, temperatures starting off early in the morning. It was a foggy day. F means fog. There was low visibility, quarter mile, and kind of a humid day too. Temperatures were in the upper 50s, low 60s, but then once the warm front came through, you can see we warmed up to around 80 degrees. Dew points were in the mid to upper 60s, so kind of a tropical feel to the air mass. And lo and behold, the observer at the airport reported a tornado was observed about 10 miles to the east at about 5:28 p.m. And it's kind of hard to read down here, but the observer put in tornado, estimated 300 injured, 50 dead, heavy destruction and property damage in the city of Worcester, a preliminary estimate. So this was back from the official observations at the airport back in 1953. And here's just another look at the actual track of the tornadoes that day. Again, the Worcester tornado moving through much of Worcester County. A couple of famous images. This is from Henry LaPrade. This is probably the most famous image. And another one showing the tornado over Shrewsbury. The photographer is unknown, but similar structure to the tornado as it passed through Worcester. And from the Worcester Telegram and Gazette, some of the damage pictures, obviously devastation from a tornado of this magnitude, an F4 with winds over 200 miles per hour. But interestingly enough, if you go to the June 1st, 2011 tornado and the Worcester tornado, boy, they look similar, don't they? They've got that wide look to them, almost very similar cloud structures. So obviously, both were formed from what was called supercell thunderstorms. But the June 1st storm formed under pretty similar conditions as the Worcester tornado did. And just to review that briefly, this was a tornado that started out actually in Westfield, passed through West Springfield and Springfield, went through Munson, Wilbraham, Brimfield, and lifted as it approached Sturbridge and Southbridge. It was an EF3 with winds of up to 165 miles per hour. It was very close to reaching EF4 intensity over Brimfield, but the damage didn't quite support that. Nonetheless, about 200 injuries and 3 fatalities. And this tornado tracked 38 miles with a max width of about 1/2 mile. So again, very similar in nature to the Worcester tornado. And of course, now in 2011, we had things like Doppler Radar, which we didn't have back in 1953. You can see the well-defined hook echo here as it's approaching Munson, and we're just passing through, and obviously very strong rotation. You see the colors are what we call tight and bright. You've got the greens against the oranges, which shows very strong rotation, and that's when the tornado was nearing its maximum intensity of EF3. And some of the damage, looks similar to what we saw in the Worcester tornado here. This was in the Springfield area, courtesy of the Springfield Republican and the Boston Globe. And of course, as it tracked into Wilbraham and especially Munson, quite a bit of damage. Neighborhoods leveled, trees flattened, just incredible damage, like certainly I've never seen before or would ever expect to see here in the Northeast. So moving on, for Connecticut, this is the Windsor Locks tornado in 1979, October 3rd. This was a track roughly from north to south. South to north, was an F4 with winds of over 210 miles per hour. This one was a little bit more of a surprise, being a late season tornado. 500 injuries and 3 fatalities, had a length of 11 miles and a width of about 1,400 yards. Quite a bit of damage in the Windsor Locks area, including at Bradley International Airport. This was the worst tornado in Connecticut history. It struck without warning. It was very sudden, which is typical of a lot of our tornadoes, especially in the fall. And interestingly enough, a United Airlines flight aborted its landing as the pilot saw the tornado just in time at Bradley International Airport. So some of the other things to look at, again, looking at the weather map, it's a little hard to see. It's in black and white, but the star is over Windsor Locks. You can see at 8 o'clock that morning, a warm front moved through. So again, we're in that warm sector of warm and humid air. And by the afternoon, actually the low was heading across the Great Lakes. We were near what's called the triple point. It's where you have the intersection of the warm front, the cold front, and an occluded front. And this is a very favorable area for tornadoes. It's very strong, what's called wind shear, changes of wind direction with height. So this was, if we were looking at this today with a little bit of advance notice, we'd certainly have our attention for the possibility of tornadoes. But back in the late 70s, not much was known about them as far as forecasting or even anticipating them. I was able to get an upper air sounding from Albany, and this was on the morning of October 3rd. And if you're not familiar with this is what the weather balloons tell us. It takes a look at temperature, which is the line on the left, and dew point, which is the line on the left. On the left, temperature on the right. It gives us a profile of temperature and wind and pressure going up all the way through the atmosphere. So just looking in the lower levels is what we focus on really for tornadoes. If we get warm temperatures into the upper 50s here, we'd have enough instability to generate thunderstorms. And the thing that stands out to me was, boy, we had a lot of turning of wind in the low levels. You can see southeast winds to start going to more southwesterly as you get aloft. And it's this turning of wind that helps the thunderstorms get stronger rotation and certainly supports tornado development. And in fact, here's some observations from Bradley Airport that day. Interestingly enough, before the tornado, the winds were out of the northeast, so we actually had even more of that low-level wind shear, winds going from the northeast to the south to the southwest as you go up a few thousand feet. The tornado wasn't observed itself at the airport. I think that's because of the heavy rain that was falling. It was most likely obscured. But there was half-inch hail, as I see here in the observation, and they did get a report of an unconfirmed tornado by the public 2 miles south of Bradley and also in Ellington, Connecticut, 15 miles to the east of Bradley. So they didn't witness it firsthand from the weather observer. Again, I think it was due to the fact that there was so much heavy rain, it was most likely obscured. And then we'll wrap up here with the Providence tornado. This was in 1986. Some of you may remember this on August 7th. Fairly short track, but it was an F2 with winds of up to 161 miles per hour. There were 20 injuries, no fatalities. It had a path length of 4 miles, which is typical, actually a little bit longer than most of the ones that we see, and a path width of about 1,000 yards. And you can see also there was another tornado just a little bit to the north that day as well. So just taking a look at the weather map that day, again, a pretty familiar theme. Low pressure to the west. We're kind of in a warm and humid air mass. There was a little bit of actually a surface trough. It's not analyzed on here too well, but as I look at this, I see a southeast wind. You can tell from the wind barb here at Block Island. Southerly wind at Bradley. So there's a little bit of convergence going on in here. The wind is kind of blowing in from the ocean and bumping into the southerly winds further inland. So that's probably what helps develop the thunderstorms that afternoon. You had the heat, the humidity, just needed a little bit of convergence to set something off. And again, we'll go back to the observations here in Providence, and not unlike the Worcester tornado started off as a kind of foggy day. This F means fog. It's temperatures around 70 overnight and dew points in the upper 60s. It's kind of sticky. Then during the morning, we warm into the mid to upper 70s. Dew points are in the low 70s. The tornado was not observed at TF Green, but the observer made a remark, reported tornado in downtown Providence with damage and possible injuries at 21:30, which would have been about 5:30 or so. And then there was a further remark, reported tornado in downtown Providence at Broad Street, many fires, much damage, 10 to 15 people taken to hospitals for injuries. That's 16:30 Eastern Standard Time, so that would have been 5:30 p.m. local time. And some of the images that we have, back in the day, we didn't have online satellite. We had them over facsimile machine, but you can see in the morning there was pretty extensive cloud cover, but a lot of breaks upstream across New York and Pennsylvania. And lo and behold, by 4:30 p.m. or 5:30 p.m. daylight time, thunderstorms had erupted in the clearing over southern New England. And these are some of the damage pictures courtesy of the Providence Journal and our friends at WPRI, TJ Del Santo. So with that takes a look at our extreme weather. Apologize if we went a little bit long, but there was a lot for us to cover, from temperatures to rainfall, snowfall, tropical systems, and tornadoes. So we're going to pause here and answer some of your questions. If Bill hasn't answered them already for you in the chat, we'll go ahead and and answer them now. So our first one is from John, going back to the heat. How much of an impact would the concrete heat sinks in place today have had on the 1911 July heat wave? Bill, you want to take a crack at that, since that's kind of your specialty?
I can try to. I'm not sure if I have I guess I don't know if I have much of an answer on that, because I mean,
I guess, yeah, if there's increased urbanization, I think that certainly
the temperature would be hotter, I would think.
Yeah, because typically, well, back then, 1911, they weren't at Logan Airport yet in Boston.
Yeah.
It was downtown. So, certainly, yeah, I mean, it's possible. I don't think it would have lasted any longer because you had that cold front coming through. Now since the 1936, the observations have been at Logan Airport. So, I guess you can argue there's a little bit of a cool bias being on the water on most days. But in these hot and humid patterns, we tend to have a pretty strong southwest wind, so it doesn't affect us as much. I mean, John, I guess it's possible. Always kind of hard to speculate, how much the urbanization would have. It certainly has more of an influence on our overnight lows. I think we see far fewer record lows, Bill, than we do record highs, from back in the day there. In fact, a lot of our record lows in the winter go back to the late 1800s. I think those are going to be kind of tough to break. All right, let's see. From Jason, another heat comment. I typically think of excessive heat brought by Bermuda high, but that may be heat index versus true temperature. Hottest seems to be more of a dry heat feed from the continental U.S. Is that accurate? You want to take that, Bill?
Sure. I mean, so the Bermuda high, I think you're kind of almost answering your own question a little bit on it. Is, with the Bermuda high, we're going to see a lot more moisture coming in off the Atlantic, and that's going to really bring us hot and humid. Whereas we get stuff from further inland where there's really not that moisture component. We get more of that dry heat, which it's that's probably why in a lot of these cases why we saw the record heat that we saw, it wasn't coming so much off from Bermuda high, but the continental air mass.
All right, let's see. Oh, good comment from our friend Fred here. He recalls being at Nantasket on August 2nd, 1975. It was 103 degrees at the beach. So, yeah, I'm guessing we had a west wind that day, Bill, or a southwest wind offshore, even hot at the beaches. So that's not too fun. Let's see. William has just a suggestion. We can include ice storms in future extreme weather presentations. Certainly. We actually covered a couple of them in our memorable storms, if you want to check that out on our YouTube channel, William. But yeah, we can certainly do that. From John, a comment: June 1st tornado and the Worcester tornado both appeared to be dry in the images, void of rain. Is this correct? Yeah, actually. They were both very typical of Midwestern tornadoes, like the ones you see in the plains, Oklahoma, Kansas, Missouri. They form when you have a lot of instability, what's called a lot of wind shear. We don't see that too often here, and really, tornadoes like that, I think, are once in a 50 or even 60-year event. They're very, very rare. But yeah, they weren't the typical ones around here that we get with heavy rain a lot of the times. Typically, the tornadoes here are very short-lived. They just be on the ground a couple of minutes. They come down quick, they go up quick, and they're usually accompanied by heavy rain, so they're obscured quite often, much like the October 3rd one at Bradley, where you're not going to see it. So good observation, John, and hopefully it's at least another 60 years before we see something like that again. Let's see, Michael, thanks for a fantastic presentation. You're welcome, and it was a lot of fun putting this together. Again, Bill did a lot of legwork redoing the model simulations, which was fantastic. From Joshua, were we impacted by the supercell that produced the tri-state tornado? I'm guessing the tri-state one you mean down in Tennessee, in that area. I don't believe so. The June 1st, if you're going back to June 1st, Joshua, and I'm not sure, that means the June 1st storms were kind of homegrown. They developed right over western Massachusetts, eastern New York, and tracked over our area. So I'm not sure if that answers your question. If not, you can just throw me a chat.
Good.
Yep.
If you don't mind, I'll interrupt you. So the tri-state tornadoes from 1925, I think maybe what you're alluding to, Josh, or the Worcester tornado, I know that some folks with the Worcester tornado, there was a tornado the day before in, I think it was in Michigan, the Flint tornado, I believe, or maybe it's Ohio, further west. And I think that folks had thought that tornado had came all the way from out there to Worcester. So maybe that's what you're trying to allude to. I'm not positive.
That's it, Bill. Good catch. I think that's what he was talking about. So perfect. Let's see, from John, was Hurricane Diane moving rapidly to maintain Category 3 strength at landfall in New England? No, I mean, it was moving rapidly, but all tropical systems tend to accelerate as they come this far north. But no, it actually, John, it maintained its core, its structure. It was a true tropical system as it reached up here in New England. So the speed doesn't really have to do with the strength of the system. It'll help enhance the wind speed, certainly on the east side, because you're adding that forward motion. But it was a true tropical system and was able to maintain its strength. Bill, for you, this is from Wayne. He saw the low temp report for Taunton at -30 or something. I think that was in your first slide on the cold. Was that thermometer accurate? I think it was.
Yeah, so I mean, I took a look at I didn't show it on those slides for that because that's the state record of 35 below zero. I looked at that day for other observation sites, and it looked pretty, similar to stuff even on I think there were some temps on the Cape that were like 20 below zero on that day. So, yeah, no, definitely accurate. I mean, I know it's on the NCEI folks have it as our state record, so I know they've vetted it with some of our partners.
All right, and we got one more question from Kevin, and then we'll move on to our weather briefing. Wants to know how much wind shear was present in the 1986 Providence tornado, and how well did forecast soundings depict this? Well, back in 1986, we didn't have forecast soundings. We had the observed soundings. This actually, the severe weather was predicted pretty well. I went back to actually was able to dig up some of the old forecasts. There was actually a severe thunderstorm watch out that afternoon for southern New England, issued by the Storm Prediction Center. Back then it was the National Severe Storms Forecast Center, but essentially the same thing. So the severe weather was expected that afternoon, and prior to the tornado, there were several special weather statements issued early in the afternoon as the storms were developing, and the office that was in Providence at the time actually issued a severe thunderstorm warning and then followed up with a tornado warning once they got word of the tornado. And the Boston office actually issued a tornado warning for adjacent areas in southeast Mass, including like Rehoboth and Dighton and down in that area, because they had heard about the tornado in Providence and saw the same storm heading into that area. It didn't produce another tornado, but it seemed like they were kind of all over it that day, which was good. Back in the mid 1980s, we were still operating. There was no internet, there were no really computer networks other than a kind of primitive network that we used that Nicole and I both started out with in our careers. But satellite pictures came over by fax. You had kind of a monitor on the Chatham radar. There certainly wasn't Doppler radar. So it was a little harder to detect severe weather, especially here in New England. But overall, it actually was expected that afternoon. So good question, Kevin. And let's see. So with that,